Hello guys, welcome back to my YouTube channel. We're still under Fluidmechanics N6. I've given this typical question. Question 1 says we have 1.1 says a 25-meter long pipe that conveys oil with a relative density of 0.9 has a hydraulic mean depth of 0.84 and it is buried at a slope angle of 10 degrees from horizontal. All right, then says here, given 1.1 says calculate the determine its diameter. We're supposed to find the diameter of this pipe, guys. Its diameter. So given the hydraulic mean depth, guys, we know that M is equals to D over 4, guys. It is in it. So the hydraulic mean depth there is 0.08. Then is equals to D over 4. We multiply by that side. We'll have 0.08 multiplied by 4. So, okay, yes, we are punching that. Our hydraulic mean depth, punching that, will get this to be 320 millimeter. All right, or meter, guys, not millimeter, sorry. Oh, 3. Okay, in millimeters is fine, but let me just leave it in meter. Let me just leave it in meter. Will be 0.32 in meter. So this will simply equals to 0.32 meter. So 1.1.2 its weighted perimeter pi multiplied by diameter. We know that pi, the weighted perimeter, is given by that formula, pi multiplied by diameter. What is our diameter there? 0.32. As we punch this, you'll get 1.005. Okay, this is what we have there. So we've seen this is 1.005 meter. All right, then says here its friction head. Want HF is friction head. HF but now because we have given the angle, if we are given the angle, guys, will be, you know this formula, sine theta is equals to HF divided by the length. Use this one if you have given the angle to the horizontal. So using this, we have sine, the angle there is 10. HF is the one that we want. The length we know is 25. So HF, you'll multiply that side, will be sine, will simply equals to sine 10. HF will be 25 multiplied by sine 10. So this will be equals to what? All right, 4,341 meter. So that is what we have so far. Those are necessary steps. 4,341 meter. All right, now we want 1.1.4 hydraulic. It's hydraulic gradient. We are talking about now I. Um 1.1.4 want its hydraulic gradient, which is simply we're talking about that. Simply talking about I is hydraulic. Now it's simple because you know this I is equals to HF over length. All right. So HF, we've just got it. Friction head is 4,341 divided by the length, which is 25. Then we're supposed to get that to be equals to guys will be 0,174. This will simply equal to 0,174, 0,174. That is what we'll have there. Its rubbing surface guys would be pi multiplied by diameter multiplied by the length. So pi multiplied by diameter, the one that we calculated there is 0,332. Multiply this by what? By the length, which is 25. This will simply equals to what? Rubbing surface will be 25,1. If I can say pi over 32 times 20. Okay, so if you punch this, you'll get this to be equals to 25,133. Obviously must be 10 meter watt squared. It's measured in meter squared. If you don't know that, why? Meter squared, remember here, diameter multiplied by the length must be that. But anyway, no problem. Let us go here. This is how it is, guys. But surface rubbing is the value that we got, 25,133 meter squared. So says here 1.6 says its friction factor if, okay, calculate there, they're talking about its friction factor if old, check old, and in roasted, rounded off to 5 decimal places. Hint, we've given these two. All right. Which one are you going to use? Remember, we have the new pipe and the old pipe. We're using this for the old, this is for the new. So be careful. That is what. So be careful about this. So let me call that 1.1.6. You know that the friction factor will be 0,01, like that. 40, the diameter is what? 0,32. Simply just punching this, we'll get this to be equals to what? To 0,010781234 obvious 5 decimal places. This is what you'll have there. There's no SI units. All right, so let's go to here, the velocity of the oil. Okay, velocity, let me just, I just made it the subject of the formula. We have HF multiplied by 2GD divided by 4FL. Remember from this formula, guys, HF is equals to FLV squared over 2GD. I made this the subject. All right, so all these values, guys, we've calculated them back then. HF, we did calculate it there on the top. We did calculate it. It's a matter of substituting now. We did calculate that. HF, then hydraulic head is this. We did calculate the hydraulic head. All of these values, guys, we did whereby it is 4.341 multiplied by 2. The gravity is 9.81 multiplied by, again, diameter is 0.32. Divide this by 4 multiplied by the friction, which is here. Here it is 0.01078 multiplied by the length. Obviously it was 25. So punching all of these, we're supposed to get this to be what? The velocity would be 5.028 obvious meters per seconds. So this is what we have, guys. Then no, that is 8, simply 8 meters per seconds. All right, so what do we have now? Here are the delivery of oil, talking about Q. All right, Q will be equals to what? Area multiplied by velocity. Area is pi over 4 the diameter, d squared, isn't it? Diameter, remember, is like this, d squared multiplied by velocity. Oh, this is like L. What I'm saying, it's area multiplied by V. This is pi over 4 d squared multiplied by V. So pi over 4, the diameter is 0.32 squared, velocity it is 5.028. Then Q will be 0.404 meters per second. This is our velocity. Then what do we have again here? The density of the oil. The density of the oil. All right, we're given that the relative density here, with the relative density of 0.9. So we know relative density is equal to the density of the substance divided by the density of what? Of water. But now the substance is what? It's oil. So I can rewrite this formula. I can say the density of what? Of oil divided by the density of what? Of water. All right. Sorry, this must be not be a density or relative density. We have given the relative density. Oh, you want the density? Okay, that is fine. Must be relative density. So what is our relative density? There was 0.9. So this is 0.9 multiplied by density of the oil. Of the water now, it's what is 1000. Then I multiply there. Multiplying there, we have P oil. Density of that is 0.9 multiplied by 1000 will be 900 is metered in kilogram per cubic meter. All right, so we have that density. Now one here they say we should determine what Chassis constant. Chassis constant, which is whereby Chassis constant is simply C. Guys, Chassis constant, all I know is C. Chassis constant, back then I know that this C will be square root of we know Chassis constant, isn't it? 2G over F. This is the formula for what? For Chassis constant. So 2 multiplied by 9.81 gravity divided by this is the one with we have found that. So punch this on the calculator. We'll have that to be 42.0 659 has no SI unit, so this is our chassis concern. So here we are done. So thank you for watching. So may you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new video.